Okay. Walaikum assalam to everybody. I hope all of you can hear me. All of you can hear me and also you can see the screen. Is it okay?
Yes, miss.
Euler's
Yes,
theorem,
ma'am.
homogeneous functions, yes. This topic was remaining in our partial differentiation section. Very important theorem. We will not look into the details, just the theorem and one or two maths. So this is Euler's theorem on homogeneous functions. At first, we look into the definition of homogeneous functions. I have written it at the bottom of this page. Yes, this is the definition of a homogeneous function. Suppose that f of xy is a function of x and y. If you just replace x by tx and y by ty. So if you replace x by tx and y by ty in the function, and if you see that this function, the transformed function can be expressed like this, say t to the power n into the original function. If after replacing x and y by tx and ty, if you see that the new function can be expressed as t to the power n into the original function. In that case, we say that this function is a homogeneous function of degree n. This n may be any real number. It may be positive, it may be negative, it may be any rational or irrational number. No problem. Okay. So this is our definition. And there is a very important theorem on this homogeneous function. This is the theorem which is known as Euler's theorem. Suppose that f of xy is a homogeneous function of x and y of degree n. In that case, you see there are two variables. Uh, the theorem states that x into del f by del x, that means x into partial derivative of f with respect to x plus y into partial derivative of f with respect to y. It will be equal to n. N is the degree of this homogeneous function, n into the original function. Okay, so this is our theorem, and this theorem can be extended for any number of variables. Here we have only two variables. If you have three variables, say x, y, z, in that case the theorem will state that x into, there will be three terms, x into del f by del x plus y into del f by del y plus z into del f by del z. This will be equal to just the same thing, n into the original function f of x, y, z. So here, no proof is needed here. I'm not giving you the proof, just try to memorize this theorem. The first question is like this: verify Euler's theorem for the following functions. Verify means at first you have to check whether the given function is a homogeneous function. If it is homogeneous, then find the value of n. Find the value of n. In that case, if you see, for the first method, there are two variables x and y. So you have to prove that x into del f by del x plus y into del f by del y equal to n into f of x, right? You have to show this. Okay, so here I'm taking the first one. This is the function. Z equal to Z is a function of x and y. So it is x to the power n log of y by x. Suppose this is this log with base e can be written as ln of y by x. And this is a function of x and y. So in place of f in the theory, here we have z. Now we will replace here in this function x by tx and y by ty. So this will be equal to tx whole to the power n into ln of ty divided by tx. So you see here t and t cancel out, and here it becomes t to the power n into x to the power n into ln of xy, y by x. And you see this x to the power n into ln of y by x, it is our original function. So here you can write z of xy. So it becomes t to the power n into z of xy. Here the particular value of n is not given, it doesn't matter. So you can say that the given function is a homogeneous function of degree n. Okay, this is a homogeneous function in xy of degree n. So you have to show that x into del z by del x plus y into del z by del y equal to nz. We have to prove it. So we have to find the partial derivatives del z by del x and del z by del y. Multiply it with x and then multiply it by y, and you will see that the result will be n into the original function. So this was our function. So now you find the partial derivative del z by del x. So here both the factors, one factor is x to the power n and the other factor is ln of y by x. Both the factors contain x. So you have to keep one factor constant and differentiate the other with respect to x. So here in the first term I am keeping ln of y by x fixed. So ln of y by x into del x of x to the power n plus x to the power n into ln of del x of ln of y by x. And the derivative of this with respect to x is what? N into x to the power n minus 1 into ln of y by x. Here x to the power n, and here this is the derivative, partial derivative with respect to x. So the argument of this log, you can consider it as simply x. So what is the derivative of ln x? Ln x means 1 over x. So it will be 1 by y by x into del x of, you see, this is not simply x, this is y over x. So you have to differentiate it again with respect to x. So the first term remains as it is, and here x to the power n into this x goes up, y comes down, and here what is the derivative of this? Here y is a constant because it is the partial derivative with respect to x. So it will be y into del x of 1 over x, and del x of 1 over x is minus 1 by x squared. And this y comes outside. So this y and this y cancel out. So you are getting n into x to the power n minus 1 into ln of y by x. There is a minus sign. And here in the upper side it is x to the power n plus 1 minus 2. This 2 is in the lower side. So ultimately the power will be n minus 1. So this is the value of the derivative del z by del x. Now we will find del z by del y. Find del z by del y. So it will be del y of this function. Here you see the first factor does not contain any y. So this x to the power n can be considered as a constant coefficient. So it will be x to the power n into del y of ln of y by x. So here this is the partial derivative with respect to y. So this whole thing y over x should be considered as y. And the derivative of ln of y is 1 over y. That means 1 by y by x. And you have to differentiate it again, this y over x with respect to y. So here this x is constant. So 1 over x can be taken outside. This 1 over x, and del y of y is just 1. So this is x to the power n, and here x goes up, x by y, and from this part you are getting only 1 over x into 1. This x and this x cancel out, so the result is x to the power n divided by y. Now you have to multiply this result by x and this result by y, and then take the sum of these two. So it will be x into, this is the value of del z by del x, and here y into del z by del y is x to the power n by y. So here y cancel out, and here it is n into x to the power n. Yes, because here the power is 1 and here it is n minus 1. So ultimately the power of x is n. N into x to the power n into ln of y by x, and here minus x into this. So it is x to the power n. This is minus sign, and there is another x to the power n. These two cancel out. Now you can take this n outside into x to the power n into ln of y by x. And this is nothing but z. So it will be equal to nz. And in this way, the Euler's theorem is verified. We have proved the relation. There is another type of question. Okay. In the first page, I have given you 3 different maths to verify Euler's theorem for these three functions. I have done this one, so these two are remaining for you. Please do it by yourself. And there is another type of math. In total, I have given here, I think there are how many? 5. Here, yes, there are 5 questions, and I think I have done only the first one. Yes. Yes, I have done the first one. What is your question? All the questions are of the same type. If u equal to tan inverse x cube plus y cube divided by xy, where x is not equal to y, because in that case, the lower part becomes 0 and whole thing becomes infinity. So x is not equal to y, show that this equal to this. The same question, u equal to this, here x is not equal to y equal to 0. So here you have to prove this. This is the type of question. So let us take the first one. So here it is u equal to tan inverse this, and you have to show this. X into del u by del x plus y into del u by del y equal to sine 2u. Okay, here you have to follow a technique. Here I have taken this x cube plus y cube divided by x minus y as z. If you do not follow this technique, your calculation will be very, very complicated, because to prove this thing, that x into what? Finally, you have to show this. X into del u by del x plus y into del u by del y equal to sine 2u. So what is your u? U means this. That means you have to differentiate this u partially with respect to x and then with respect to y. You see, it is not so simple. Tan inverse this whole thing. So the partial derivative will not be so easy. So that's why you please follow this technique. Suppose that x cube plus y cube divided by x minus y, suppose it is a function of x and y, name it by z. Okay, so if this is your z. So from this relation, what you are getting? U equal to tan inverse z from this relation. So u equal to tan inverse z, and you know from this relation you can write z. Z will be tan of u. If u equal to tan inverse z, z equals to tan of u. Okay. Now we want to see. We will apply our Euler's theorem on this function, not here. We will apply the Euler's theorem on this function. So you have to check whether this function is a homogeneous function, and if it is homogeneous, find the degree of it. So we replace this x and y by tx and ty. So z of tx ty will be t cube x cube plus t cube y cube divided by tx minus ty. In the upper part, you can take t common. T cube. Yes.
মিস ইউ তো আমার অরিজিনাল ফাংশন ছিল তাই না? এখন এখানে জেডটাকে যে অরিজিনাল ফাংশন করে ফেলেছে, z is the function of x.
Z is not the original function. I have considered, I have assumed this whole thing, the argument of this tan inverse z, tan inverse this as z. I have assumed this thing as your z, and this z contains x and y. So you can think of this function as a function of x and y. That's all.
Okay, miss.
You are using an assumption here, that this whole thing, you are naming it as a function of x and y, and this function is z. Okay. Now, if you can show that this z is a homogeneous function of some degree, then you can apply Euler's theorem on this function, isn't it? If you can show that it is a homogeneous function of some degree. So that is the thing we are going to do. So you replace x by tx and y by ty. So here you can take t cube common. So there remains x cube plus y cube, and take t common from the lower part. So it will be t into x minus y. Now you see that this t cube and t, after cancelling, you will get t square. And what remains here? T square into this, and this is nothing but a z. This is nothing but z. So this whole thing, z of tx ty is equal to t square into z of xy. What does it show to us? It shows that this z of xy is a homogeneous function of degree 2. Isn't it?
Yes, miss.
Okay.
Yes, miss.
Yes. So since this z of xy is a homogeneous function of degree 2, you can use Euler's theorem on this function. So your function is z and the variables are x and y. So using Euler's theorem, you can write it like this: x into del z by del x plus y into del z by del y into del z by del y equal to n is 2 here. So 2 into z. Am I right? Just use Euler's formula. Because z is a homogeneous function of degree 2. So in place of n, you have 2. So using Euler's theorem, you will get this. X into del z by del x plus y into del z by del y equal to 2z. Now here you just put down the value of z. What was our z? Our z is tan of u. Your z is tan of u. So you put here z equal to tan u here, here, and here. So it means del x of tan u. You see here, this is in as a function of u, but here you have to find the partial derivative with respect to x. So let us write it in this way: del u of tan u into del u by del x. Just use the chain rule from partial differentiation, okay? Because here the function is of what? It is a function of u, but you have to find the partial derivative of this thing with respect to x. So let us write it like this: del u of this thing into del u by del x. Same thing here. It will be what? Del u of tan u into del u by del y. Here you are writing it del u, so you have to multiply by del u by del x, because here it was with respect to x and here it is with respect to y. So if you write it del u, you have to multiply it by del u by del y. Now, what is the derivative of this tan u with respect to u? It is simply sec square u. You know what is the derivative of tan x? Tan x gives you what? Sec square x.
Sec square x.
Right. So here, derivative of tan u with respect to u, it will be sec square u. So you are getting here x into sec square u into del u by del x, plus here again y into sec square u into del u by del y. So now you divide both sides by sec square u, because in the left side you need the x into del u by del x plus y into del u by del y. So if you divide by sec square u, that means 1 over sec square u, and 1 by sec square u means cos square u. So in the right side it will be 2 into tan u into cos square u, and tan u means sin u by cos u. So 1 cos u cancel out. You have here 2 sin u cos u. Just use the formula sin 2u. Sin 2u means 2 sin u cos u, and you are getting the result. This is the result you have to prove: x into del u by del x plus y into del u by del y equal to sin 2u. Okay, so this is the math, and in all the remaining maths you have to follow the same technique. I'm just showing you one thing. You see, in the second math, it is what? A log of, it is actually ln of x square plus y square divided by x plus y. Just take it as your z. Okay? Ultimately, just follow the same technique that I have done here in question number 1. Here you have to take this x square plus y square by x plus y as your u. Here you have to take root over x minus root over y divided by root x plus root y. This whole thing as your what? This is z, so take it as u. Here it is z. Already it is z, so here you cannot take z. You have to take another variable, cu. Okay, similarly, here it is z equal to sine inverse this, so take this whole thing as u. Okay, and just follow the technique that we have done here in this math. Okay, so this is the end of your partial differentiation. I am closing it. And I am taking another one. So, can you see the screen? Integration by parts.
Miss.
Huh?
Yes.
Okay. So, you see, our partial differentiation is complete. So now we are starting integration. At first, integration by parts.
Miss, we
I
cannot
know.
see.
মিস দেখা যাচ্ছে না।
ম্যাম স্ক্রিনটা শেয়ার হয়নি।
Okay. Just a minute. Just a minute. I forgot to share it. Now,
Yes, miss.
so you see, we are now starting what? Integration, and the first topic is integration by parts. I know all of you have done this thing, integration by parts, in your HSC classes and in IUB also. Did you have any previous course on this calculus, differentiation and integration?
Yes, miss.
I think it was one, right.
ইয়েস মিস।
The course number was 104, so you have already done a course on this basic things, integration by parts. So this is a basic actually in this course, Maths 203, it is the basic thing, basic topic. So what was the formula? You just go through the formula at first. If it is like this, integration of the product of two functions, one function into another function. You have to choose any one of these two as your first function and the other as second function. Please remember, you have to choose that function, that particular function as your second function, which can be easily integrated. The function which is easily integrable, you have to choose that one as second function, because in the formula you have to integrate the second function. Okay, that is the main theory. If one of these two functions is easily integrable, take the easily integrable one as the second function and the remaining one as first function.
Miss, তাহলে ফার্স্টটাকে ইন্টিগ্রেট করব না?
No, the formula is this. Here I have taken fx as the first function and gx as the second function. This is your formula. First function into integration of second function. Then minus whole integration. Put a big integration sign. Then use the second bracket. And within this second bracket, at first comes ddx, differentiation of the first function. ddx of fx into integral of the second function. The same thing. Integration of the second function, and then close the second bracket and put another dx here. You see, this dx is for this inner integration, and this dx is for the whole integration, this one. So under this whole integration, you have to do two things. Two operations are there. Under this whole integration, there are two operations, ddx of the first function into integration of the second function. Whatever you get here, finally you have to integrate on this whole thing. This is your formula. So at first you have to check which function is easily integrable. That function to be taken as the second function. Number two, if you see that both the functions are easily integrable, in that case you have to choose the first function, which after differentiation becomes with less power. Because when you differentiate, suppose there is x to the power 5. If you differentiate it, the power of x will be 4, isn't it? So if both the functions are easily integrable, in that case you choose that particular function as the first function, which becomes with less power after differentiation, which becomes more simple after differentiation. Okay, so this is your formula. Try to memorize it. So here, look into this. This is the most easy function to be integrated by parts. X squared into e to the power minus 2x. You see, both the functions are easily integrable. You can integrate x squared, you can integrate e to the power minus 2x. Both the functions are easily integrable. What is the integration of this x squared? Can you say?
X cubed by
X cubed by 3, yes. Integration of x squared is x cubed by 3. And what is the integration of e to the power minus 2x?
And e to the power
e
minus
to the power minus 2x divided by
mx এর formula আর কি
minus
Yes.
2.
Divided by minus 2, right. So here you see both the functions are easily integrable, but you see if you take this x square as second function, the power of x will be increased. It will be x cubed by 3, but we don't want it. If you take this x square as your first function and you take the d dx, it will be twice x. So you see the power of x becomes smaller. Okay, so that's why here we have chosen this x square as the first function and this function as your second function. So what is the formula? First function into integration of the second function minus whole integration of, I have written down the result directly, d dx of x square. d dx of x square is 2x into integration of this second function and then another dx for this whole integration sign. So here integration of e to the power minus 2x is e to the power minus 2x by minus 2. X square remains here and you can take this 2 outside. So here remains x into what? Integration of this inner integration, it will be e to the power minus 2x divided by minus 2. So in the next step, this minus minus gives you plus sign and these 2 to cancel out. So here you are getting minus half x square e to the power minus 2x then plus integral of what? X into e to the power minus 2x. So you are getting almost the same thing, just here the power was 2, now here the power is 1. So you have to perform this integration again by using integration by parts method. So here again we will take this x as first function and this one as second function. No change in the first term, it will be there, always there as the first term into integration of second term minus whole integration of d dx of the first function into integration of second function. Now it is easy, d dx of x is 1. Here it is e to the power minus 2x by minus 2 and here e to the power minus 2x divided by minus 2. So this minus minus plus half into integration of this e to the power minus 2x, so which will give you e to the power minus 2x divided by minus 2. And there must be an integration constant because it is an indefinite integral. It is indefinite integral. After performing the integration, you have to put a constant. So this is your result. This is your result. This is easy for you. You see, both the functions, I'm not going through the details, just I'm giving you the starting. You see, x square and sine x, both of them are easily integrable. But you see, if you take x square as the first function, after taking the differentiation, d dx of x square will be less, just 2x. That's why you have to choose this x square as first function and sine x as the second function. Okay, let us now do this. Integration of Lonics whole square. Okay, just tell me, can you integrate Lonics directly? Is it possible?
no miss
No,
We have to substitute.
no, it is not possible because you know the differentiation of Lonics, it is 1 over x. But integration of Lonics, whenever you have an integration involving ln x, you cannot take ln x as the second function because ln x is not easily integrable. So whatever with the function involving this ln x, you have to take it as your first function. So you see there is only one function here, one factor, ln of x whole square. So you have to consider another into 1 here, ln of x whole square into 1, because there was no other factor here. Only one factor, ln x whole square. But you cannot take this ln x whole square as your second function. You cannot integrate it directly. So that's why you have to consider into 1. And then this part should be taken as your first function because it is differentiable, but it is not integrable so easily. So this one should be taken as your second function. Okay, please remember it. If you have any type of function involving ln x, you cannot take this function involving ln x as your second function because it is not easily integrable. If there is nothing else, then you have to consider a 1 here. There may be an x here. In that case, x should be taken as the second function. but there is no other function here, so we have written down a 1 here, and you take this one as your second function. So first function ln x whole square into integral of the second function, integral of 1, just 1, that means integral of dx. And here whole integration of d dx of the first function into integration of the second function, and then close this bracket, put another dx here. So integral of dx is x. You know, integral of x dx is x. So x into ln x whole square. And what is the integral of this? It is d dx of ln x whole square. So you have to take this ln x as single x, single x. So x square gives you 2x. That means it will give you 2 ln x. But this is not simply x, it is ln x. So you have to multiply the result by what? D dx of ln x. And d dx of ln x is 1 over x. It is coming from what? D dx of ln x. D dx of ln x is 1 over x, and integral of dx is x. Okay, so you see this x and this x, they cancel out. So ultimately you have only ln x. So here the first term does not change, it remains here until the last step, till the last step. So 2 into ln of x, there is no other function, just 1 here. So again you have to perform the integration by using integration by parts, and then you have to consider this ln x as the first function and this 1 as the second function. There is a 2 outside, so putting this 2 outside, use a third bracket. So first function into integration of second function minus whole integration d dx of first function into integration of second function. So integration of dx, it gives you x, so x into ln x minus d dx of ln x. It is simply ln x, so it will give you directly 1 over x. And from the integration of this dx, it will give you x. So x cancel out, there remains only just integration of dx, which will give you x. Anyway, there is a 2 outside, so x into ln x whole square minus 2 into what? X into ln x. This sign will be plus 2 into integral of dx, which gives you x. So this is your result. Put an arbitrary constant. Okay, there is another integration. This also involves ln x. You see, here ln x divided by root over x. This 1 by root over x is differentiable, it is also integrable, but this ln x is not easily integrable. So you have to take this ln x as your first function and 1 by root over x as your second function. Okay, so ln x, first function into integration of second function, minus d dx of first function ln x into integration of second function. And here integration of 1 by root over x. 1 by root over x means x to the power minus half. So it will be ln x here, and you know the formula, integration formula, x to the power minus half plus 1 divided by minus half plus 1, and then minus d dx of ln x is 1 over x. And for this integration in the inner part, within the bracket, you are getting this x to the power minus half plus 1 divided by this. So here in the lower part you will get half, so when you take it to the upper side it will be 2, and x to the power minus half plus means x to the power half, and x to the power half means root over x. So the first term can be written like this: 2 into root over x into ln x. Don't write this root over x here, because ultimately in the next step you will write it as x into root over x, not like this. This root over x should be multiplied to this whole ln of x. This is a common mistake that you do. You write your root over x at here, and in the next step you write ln of x to the power 3 by 2, which is totally wrong. So be careful. And here it is 1 over x into again x to the power half, root over x, and from the lower part half, when taken upper side, it becomes 2. So this gives you what? Root over x by x, that means again 1 by root over x. So finally, you are getting this. 2 into root over x ln x, and this half when taken upside give you 2, so 2 into 2, 4, and x to the power half means root over x plus some constant. Look into this. X into tan inverse x. Please tell me which one should be taken as the first function?
মিস
Huh? Yes.
এখানে একটু ভুল মনে হচ্ছে না মিস x টু দ্য পাওয়ার রুট x টু দ্য নিচে হচ্ছে মিস টু হাফ থাকার কথা না, যে জায়গায় হাফটা আপনি উপরে নিয়ে আসছেন
Where?
এটাকে
In this
আমি জি মিস এই 5 নম্বর লাইনটা নিচ থেকে উপরের দিকে 5 নম্বর লাইনটা এই যে ln x ইনটু x টু দ্য পাওয়ার জি মিস এটা ফার্স্ট পার্ট
okay. ddx of ln x is 1 over x.
এটা বাম পাশটাই
Is it okay? Here.
জি মিস এটার নিচে হাফটাকে উপরে নিয়ে আসা একটু হইছে, সেটা লিখছেন ডিরেক্ট পরের লাইনটাই
1 by x to the power 1 by root over x means what? Tell me. 1 by root over x means what?
ওটা না মিস
1 by x to the power
ঠিক
half.
আছে।
Very simple algebra. 1 by root over x means 1 by x to the power half. And when you take this x to the power half from the lower part to the upper part, it will be x to the power minus half.
মিস 2 রুট x ln x আমি সেটার কথা বলতেছি। 2টা কি হচ্ছে নিচের হাফটাকে উল্টাই দেওয়া 2 আসছে।
এছাড়া আর কি?
হ্যাঁ মিস ওটাই।
Minus half plus 1 means what? Half. Minus half plus 1 means half, and it is in the lower part. So if you take this half to the upper side, the 2 will be upper side.
এটাই মিস কনফিউজ হয়ে গেছে।
It is a very simple algebra from class 5 or 6. Your half is in the denominator. 1 by half, it means what? It is just 2. 1 by half means what? Tell me. 1 by half means what? Please tell me.
2 মিস
2. 1 by 2 by 3 means what? 1 over 2 by 3 means what? Tell me.
3
2 by 2
3 by 2.
3 বাই
So could it be the question? Huh? Could it be a question? Anyway, so you see when you take this, if this half is in the denominator, it will be ultimately, it will give you 2. Any other question from this part? Any more question from this math?
no miss
Okay. So now here, now please tell me which factor should be taken as first function and which one as second function?
miss tan inverse x first,
Tan inverse x should be
first function
first function, because you cannot integrate tan inverse x directly. It is not possible. It is not possible. If you have, there is an x here, so if you do not have any x here in no other function, just tan inverse x, in that case, just the previous math, you have to consider a 1 here, 1 into tan inverse x. In that case, tan inverse x should be your first function and the second function should be 1. Here we have x, so this tan inverse x should be taken as the first function and this x should be taken as the second function. So here, first function into integration of second function minus whole integration of what? Second bracket d dx of first function tan inverse x into integration of x dx, and then close the second bracket, another dx here. Now, integral of x gives you what? X squared divided by 2. Integral of x gives you x squared by 2. And here, you have to know the formula for tan inverse x. Tan ddx of tan inverse x is what? 1 by 1 plus x squared. Do you know it?
yes miss
You have to memorize this formula, basic formula. ddx of tan inverse x is 1 by 1 plus x squared. And for this integration, you are getting x squared divided by 2. Okay, so this half can be taken outside and this term will be there in the first term till the last step. And here you take this half common outside, and here remains what? X squared by 1 plus x squared. And this is a very common technique. You see, in the lower part it is 1 plus x squared, and in the upper part it is simply x squared. So let us write it like this: 1 plus x squared minus 1. Very simple and very important technique. Very simple but important. You have in the upper part x squared, in the lower part 1 plus x squared. So let us write the upper part like this: 1 plus x squared minus 1. Suppose you have, in place of 1, suppose you have 4. In that case, you have to write 4 plus x squared minus 4. It will make your integration easy. So I am writing here 1 plus x squared minus 1. Then in the next step, you separate these two terms. The first term will give you what? 1 plus x squared divided by 1 plus x squared. That means simply 1. So just integral of dx. And from the second part, this minus and this minus gives you plus sign. So half into what? Integral of dx divided by 1 plus x squared, because the upper part is simply 1. Okay, now here integral of dx, it gives you x, so minus half x. And what is the integration?
আবার হাফ আসলো কোথা থেকে?
এই যে একটা half ছিল, এই যে একটা half ছিল, this half. This half was here outside, so this half should be multiplied to both the terms. Here the first term is simply 1 and the second term is minus 1 over 1 plus x squared. But you have to multiply this half to both the terms, isn't it?
Yes, miss.
So the first term will be minus half into integral of 1 dx, and the second term will be this minus, and this minus will give you plus half into, this is 1, so dx divided by 1 plus x squared. And now you must know this integration. What is it? Tan inverse.
Tan inverse 6.
Yes, because d dx of tan inverse 6 is 1 by 1 plus x squared. You know, differentiation and integration are just the what? Inverse operation. Inverse operation. So d dx of tan inverse x gives you 1 by 1 plus x squared. So if you integrate 1 by 1 plus x squared, you will get what? Tan inverse x. Okay, so this is the result. Now this method, integral of sine of Lonics. This Lonics is the argument of sine, not simply x. It is not simply sine x, it is sine of Lonics. Now please tell me, can you integrate this sine of Lonics directly? Is it possible?
No, miss.
No, it is not possible. You can integrate sine x, isn't it? You can integrate sine x. What is the integral of sine x? Tell me.
Minus cos x.
Minus cos x, right. Integral of sine x is minus cos x. But here it is ln of x. If it is simply, say, sine of 3x, it is possible. Integral of sine of 3x, it is possible. It will be minus cos 3x divided by 3. Just divide by the constant coefficient. Here it is not a constant, it is ln of x, another function of x. So it is not possible to integrate this function, sine of ln x. And there is no other function here, so you just consider a 1 here. Integral of 1 into sine of this. And then you have to take this sine of ln x as your first function and 1 as the second function. Very important. So sine, first function, this is your first function into integration of second function. Your second function is 1, just 1. And whole integration of what? Put a second bracket, d dx of the first function. So d dx of sine of ln x into integral of dx, close the second bracket, another d. This dx is for the whole integration. So here integral of dx is simply x. Put this x to the left of this sign. Okay, it is better, but because if you put your x here after this ln x, you may multiply this x with this ln x. You do it. Some of you do it, and it is a very gross mistake. So at the first step, you put this x to the left of this sign. So x into sine of this minus d dx of sine of ln x. So here this ln x should be considered as simply x. d dx of sine x is cos x. So cos of ln x, but it is not simply x. So you have to multiply by what? d dx of ln x, and d dx of ln x is 1 over x. d dx of this ln x is 1 over x. And this integral of x, integral of dx is x. So this 1 over x is coming from this ln x, and this x is coming from this integration. So this x and x cancel out. So in the next step, you are getting what? X into sine of ln x, it will be there. And here x is cancel out, so you are getting cos of ln x. So similar type of function like this. So again, you have to perform this integration, just considering a 1 here. 1 into cos of this. So 1 should be taken as the second function, and this cos of ln x should be taken as the first function. So we apply integration by parts again on this part, on this term. So first function, use a third bracket here, minus sign outside, third bracket, first function into integration of second function, minus whole integration of d dx of the first function into integration of the second function. Close the second bracket, put another dx here, and then close the third bracket. So here you are getting what? From this part you are getting x into cos of ln x. So if you remove this third bracket, it will be minus x into cos of ln x. And here there was a minus sign, but here when you take the ddx of cos of ln x means you just consider this ln x as simply x, and ddx of cos x is minus sin x. So minus and minus gives you plus sign, and this plus and this minus gives you minus sign. So it will be integral of sine of ln x into, it is not simply x, it is ln x. So you have to multiply this result by ddx of ln x. And ddx of ln x is 1 over x. And integral of dx gives you x. So again, this x and x cancel out. So what remains here? X into sine of, this is ln of x. I have taken here x common anyway. X into sine of ln x minus cos of ln x, and this becomes minus integral of sine of ln x dx. So you see, you are getting again the same integration from where you started. You started from this, and you are getting again this. So just take this term to the left side. Take it to the left side. So it will be this plus this. That means 2 into integral of this, because these are actually the same term. So 2 into this equal to this. So to get the result of this integration, just divide by 2. So the result will be half x into this. Okay, there should be a constant term here. I forgot to put the constant term. Okay, you will go through it by yourself, because we will establish a formula for e to the power ax and cos bx. Now comes the definite integral. Just a minute. So this is a definite integral. The limits are 1 up to e x square ln of x dx. Now, by now we know that ln x cannot be taken as a second function, because ln x is not easily integrable. So this x square should be your second function, and this ln x should be your first function. So what is the formula? First function into integration of second function. Be careful, here you have to put the limits for the whole of this. Sometimes it is a very common mistake. Very common mistake. I repeat, it is a very common mistake. You forget to put this limit for this ln x. You just write like this. Ln x into integral 1 up to e x squared dx.
মিস ফার্স্টে যদি ইন্টিগ্রেশন করে একদম লাস্টে গিয়ে ডেফিনেট ইন্টিগ্রালটা করে অ্যানসার দিই, তাহলে কি হয়?
হ্যাঁ, নো প্রবলেম।
না, লাইক আগের থেকে আপনি দিয়েছেন না, এখানেই লিমিটটা বুঝছেন।
So that you are saying that just find the value of the indefinite integral x square ln x dx, and then in the final step you put the limits. Yes, this is also okay. This is also okay. But if you want to do it directly, please remember for this term you have to put these two vertical line or third bracket. Then you have to put the limits for the whole of this. Don't forget to put the limits for this ln x. It is ln x into integral of x squared dx and then put down the limits for the whole thing. And then minus whole integration, here the limits should be there 1 up to e, and the same formula d dx of the first function into integration of the second function. So here the integral of x square is x cubed by 3 into ln of x and the limits 1 up to e. And here d dx of ln x is 1 over x, integral of x square is x cubed by 3. So ultimately you can take this 1 over 3 outside and 1x cancel out. So integral limit 1 up to e x square. Now if you put the limits here, it will be, you can put this 1 over 3 outside, it will be e cube into ln of e minus 1 cube means 1 into ln of 1. And you know ln of 1 is 0. Do you know it? Ln of 1 is 0, and what is the value of ln of e?
1.
1. Yes. Ln of e means it is log e with base e. If the base and the argument are exactly the same thing, the value is 1. So this gives you 1 by 3 e cube. This gives you 0. And then here comes x cube by 3. 1 over 3, this 1 over 3 is here, another x cube by 3, and then put down the limits 1 to e. Then this is simple algebra. You are getting this result. So another definite integral. Here also the function involves ln x. You see, now it is ln x divided by x squared. So again, this ln x should be your first function. It cannot be second function. Ln x into integral of second function. Integral of second function means what? 1 by x squared. So don't confuse. 1 over x squared means what? X to the power minus 2. X to the power minus 2, and when you use the formula, integration formula, it will be x to the power minus 2 plus 1 divided by minus 2 plus 1. That means it will be x to the power minus 1 divided by minus 1. So this minus sign here, and x to the power minus 1 means 1 over x. Okay, x to the power minus 1 means 1 over x, and this ln x, and you have to put the limits for the whole thing, root over e up to e. And here d dx of ln x is 1 over x, and the integration we have already got here. The result is minus 1 over x. So this minus and this minus will give you plus sign and 1 over x. So ultimately it is 1 by x squared. So when you use the formula, 1 over x squared means x to the power minus 2. So x to the power minus 2 plus 1 divided by minus 2 plus 1. And the limits root over e to e. Now you put down here the limits. So you can put this minus sign outside. At first you put the upper limit. So 1 over e into ln of e, and then use the lower limit. So it will be 1 by root over e into ln of root over e. And here it is this minus 2 plus 1 gives you minus 1. So minus 1 will be here. And it means 1 over x root over e to e. So here 1 by e, ln of e is 1, so 1 over e, and here it will be what? You see, just use the property of logarithmic function. Ln of root over e means ln of e to the power half, and ln of e to the power half, this half can be taken to the left side of this ln. So this half will be here, and here remains simply ln e, and ln e is 1. So ultimately it will be simply 1 by 2 into root over e. So you please go through the, if you forget it, please go through the properties of logarithmic function. The main property is log of xy equal to log x plus log y. If you have log x plus log y, you can write log of xy. If it is log x minus log y, it will be log of x by y. And if it is log of, say, x to the power n, it is equal to n into log of x. We have used that property here. Log of x to the power n equals to n into log x. So here it is ln of e to the power half. So it will be half into ln of e. Ln of e is 1, so simply half. Now do the algebra. This is your result. I think you can do this thing, so I am doing this one. function involving sine inverse x. We have done a math involving tan inverse x. Now look into this. This function involves sine inverse x. There was no other function here, no other factor here, only sine inverse x. You know this sine inverse x cannot be integrated directly. That's why you have to consider a 1 here and consider this sine inverse x as your first function and 1 as the second function. So first function into integration of second function and put the limits for the whole of this. And then minus whole integration 0 to root 3 by 2 d dx of the first function, d dx of sine inverse x into integral of 1 dx. Close the second bracket, dx outside. So integral of dx is x. So x into sine inverse x and then the limit 0 to 3 by 2. Here, what is the d dx of sine inverse x? It is 1 by root over 1 minus x square. d dx of sine inverse x is 1 by root over 1 minus x square and integral of dx is x. So ultimately it is x divided by root over 1 minus x square. Any question here? Any question here?
No, miss.
Okay. So this is okay. In the next step, you just put down the limits. It will be root 3 by 2, sine inverse root 3 by 2. And for the second term, 0. 0 into anything is 0. So only the first term involving the upper limit. And here, you have to use a substitution to perform this integration because it is x by root over 1 minus x square. Let us take 1 minus x square as z, another variable. 1 minus x square equal to z. You know the substitution method. Here you have to substitute for this 1 minus x square, which will give you x dx. So now you take the differential. Differential means differential means what? d dx of this whole thing into dx. That is known as differential. d dx of this into dx. So d dx of this means what? Minus 2x because 1 gives you 0 and x square gives you 2x. So minus 2x into dx equal to dz. So what is the value of x dx? Here we have x into dx in the upper side. So x into dx equal to minus dz divided by 2. Okay, so minus dz divided by 2. This minus and this minus sign gives you plus sign, and these 2 dz by 2, this half is taken outside dz. And what about this thing? It will be dz divided by root over z. Because this 1 minus x square is taken as z, so it will be dz by root over z, and you must change the limits. You must change the limits. Here your substitution is this 1 minus x square equal to z. So when these are the limits for x, 0 to root 3 by 2. When x equal to 0, z will be 1. Yes, when x equal to 0, z will be 1. Now when x equal to root 3 by 2, so it will be 1 minus 3 by 4. Yes, z should be equal to 1 minus 3 by 4. That means 1 over 4. So the limits will be 1 up to 1 by 4. The limits will be 1 up to 1 by 4, and here x dx was minus z dz by 2, minus half is taken outside. So now this is your integration, dz by root over z. Root over z means what? Z to the power half, and when you take it to the upper side, it will be z to the power minus half. So after integration, use the formula, it will be z to the power minus half plus 1 divided by minus half plus 1. Now simplify it. In the lower side you are getting half, so in the upper side it will be 2 to cancel out, and z to the power minus half plus 1 means z to the power half. Z to the power half means root over z, and the limits are 1 up to 1 by 4. So in the next step you just put the limits, root over 1 by 4 minus root 1, and root over 1 by 4 means half. Half minus 1 will give you minus half. So this is your result. And you know, when you have a definite integral, there will be no constant. You know it? Do you know it? If your integral is a definite integral, there cannot be any constant, because for the limits, ultimately the constants cancel out. So when you have a definite integral, don't put any constant. Okay. Now I am doing this. Okay, shall I do it? No, I will not do it. It is given here. I will go to the very important integrations. If I get time, I will come back. Okay. Very important. Integral of e to the power x cos bx dx. You have to evaluate it. You have to find the value of it using integration by parts. There are two functions. So suppose that this name is just I equal to this, and here both the functions are easily integrable. Both the functions are easily integrable. Here I have chosen cos bx as the second function and e to the power ax as the first function. So first
Why
function,
not? কিভাবে চুজ করলেন?
here you can choose e to the power ax as second function, cos bx as first function, no problem.
Okay.
Ultimately, you will get the same result. Okay. One thing, just one thing you have to know, that you have to perform another integration by parts in between steps. So the first function you chosen here, you have to choose the same thing as your first function. If you change it, you will get no result. So here I have chosen this one as first, this one as second. But if you choose cos bx as your first function, e to the power ax as your second function, no problem. You will get the same result. Is it okay? Is it okay?
Yes. Yes.
Yes, you can do it. You can check. You can check it by yourself. So first function into integration of second function, because here it is up to you. It is totally up to you, because both the functions are easily integrable and none of them becomes with less power after differentiation. Because d dx of e to the power x is what? A into e to the power x. Is the power becoming smaller? No. So it is totally up to you. You can choose this one as first, this one as second, or this one as first, this one as second. No problem. So first function into integration of second function, then whole integration d dx of the first function. First function is e to the power ax into integral of the second function. Okay, what is the integral of this cos bx? This b is a constant. No problem. So your integral will be sine bx divided by b. If this x is multiplied by a constant factor, you can directly integrate it. Just divide the result by this constant coefficient. That's all. So e to the power x into sine bx by b. And here, for this differentiation, you are getting a into e to the power ax. So you can put this a outside, and from this integration you are getting sine bx divided by b. So this b also can be taken outside. So here I have taken this a from this part in the upper part, and from this part b in the lower part. So you are getting another integration e to the power x into sine bx dx. What I want to tell you that here your e to the power ax was first function and this one was second function. So when you apply integration by parts here, you have to take e to the power ax as the first and sine bx as the second. Is it clear to you?
Yes, miss.
Yes, just try to remember this. The function that you have chosen here as the first, here also you have to choose it as the first one. That's all. So here I am taking a by b common, put a third bracket. So this is your first function into integration of second function. Then minus, this whole thing is within this third bracket, minus whole integration d dx of the first function into integration of the second function. Okay. Here, integral of sine gives you minus cos, you know it. So it will be minus cos bx divided by b. Yes. So within the third bracket, minus a by b remains outside. Within the third bracket, it will be e to the power ax into minus cos bx divided by b. And here, this e to the power x gives you a into e to the power x. So take this a outside, and integral of this sine bx gives you minus cos bx divided by b. So this sign will be plus, and this b in the lower part, take it outside, this integral. So ultimately you are getting this thing, and in the next step you remove this third bracket. So this sign will be plus. Plus into what? A divided by b into b square. A by b square e to the power ax into cos bx. Then this minus and this plus sign give you minus sign. A by b into a by b. So it should be a square by b square into integral of e to the power ax cos bx. So you see, you are getting the same thing from where you started. Integral e to the power ax cos bx dx. Here, after performing the integration by parts twice, you are getting the same thing. So this integral means it is I. So let us take this term to the left side. In the left side it was I. So you can take I common. So the term that was already in the left side, if you take I common, there will be 1, I into 1, and then when you take this term to the left side, if you take I common, it will be 1 plus a square by b square equal to. Now you take the LCM of these two terms, it will be b square. So here comes b into e to the power ax into sine bx, plus here it will be a into e to the power ax cos bx. So this becomes the left side, and here in the upper part you just take common e to the power x, take e to the power x common. So e to the power x into it, I am writing this term first, a into cos bx plus b into sine bx divided by b square. So in the left side you do the sum, it will be b square plus a square, and then in the next step you divide by this whole thing. You divide by this whole thing, so this b square and this b square will cancel out, and here in the right side this a square plus b square will come in the denominator. So this is your result, and you know this result can be used as a standard result. This is the standard result. Sometimes when you do differential equations, sometimes you may get this type of integration. In that case, you can use this result directly. In that case, you can use this result directly. But in this part, say in integration by parts, you are asked to find the integral of e to the power, say 2x cos 3x dx. In that case, you cannot use the result directly. You have to perform this integration just like this. You have to follow all these steps. But you can use this standard result when you perform, say, in case of you are solving a differential equation, and there you are getting an integration like this. In that case, you can use this result directly. I'm not doing the second part. It is exactly the same thing. E to the power ax sine bx. Here we have done it with cos bx. It was e to the power ax cos bx. Now it is e to the power x sine bx. It is done here. You just go through it by yourself, and the result is this. This is the result. It will be e to the power, same type of result, but a little change here. E to the power x by a square plus b square is common, but here it is a sine bx minus b cos bx. But when it was cos bx, it was a cos bx plus b sine bx. That is the difference. That is the difference. Okay. I wanted to give you the formula. Okay, it is in the last page. The formula is given here. These are the basic formula, you see. d dx of x is 1, d dx of this. Okay, actually if it is, okay, in case of d dx, differentiation, the power becomes less. It will be r into x to the power n minus 1. And if it is x to the power r plus 1, it will be just x to the power r. d dx of sine x is cos x, d dx of cos x will be minus sine x, d dx of tan x is sec square x, and d dx of cot x, it will be minus cosec square x. d dx of sec x is sec x tan x. These are the integration. You see, integral of x to the power r dx, it is x to the power r plus 1 divided by r plus 1. Here, r cannot be equal to minus 1, because if r equals to minus 1, the whole thing becomes infinity. If r equal to minus 1 means what? It is actually 1 over x. X to the power minus 1 means 1 over x, and integral of 1 over x is Lonics. You see, integral of cos x is minus sine x. Integral of sine x will be minus cos x. Integral of sec square, you see, just the inverse process. d dx of tan x was sec square x. So the integral of sec square x will be tan x. d dx of cot x was minus cosec square x. So integral of cosec square will be minus cot x. Integral of sec x tan x will be sec x. Okay. D dx of minus cosec x. D dx of cosec x is cosec x cot x. So integral of cosec x cot x will be minus cosec x. D dx of e to the power x is e to the power x. So integral of e to the power x will be e to the power x. So you can go through this formula by yourself. These are the basic formula. If these things are not in your mind, if it is not in your memory, okay, if this formula are not in your memory, then it will be tough, hard for you to evaluate an integral. Ln of x, d dx of ln x is 1 over x, d dx of tan inverse x is 1 by 1 plus x square, d dx of sine inverse x is 1 by root over 1 minus x square, d dx of sec inverse x is 1 by x into root over x square minus 1. And these integrals are just the opposites of this. So here if you integrate 1 over x, it will be ln of x. Here the modular sign is used because you know this argument of ln must be a positive number. If argument of ln is a negative number, it becomes infinity. That's why this modular sign is used here. So tan inverse x gives you 1 by 1 plus x square. So if you integrate it, it will give you tan inverse x. That's all. Okay, so it is not the way to memorize it like this, that d dx of sine x is cos x, d dx of cos x is sine x, not to get these results in memory by like this. You have to do, if you do as many as problems you can do, it will be in your memory automatically. Automatically it will be in your memory. If you do a lot of math on this differentiation and this integration, automatically it will be, the results will be in your memory. Okay, so don't try to memorize by repeating, by saying the results repeatedly. It is not the way to memorize it. Okay, so here let us do something here. Okay, let us do this math. Integration, because we have time, integration 2 up to 4, integration 2 up to 4 sec inverse root over theta d theta. Now look into this. If it is simply sec inverse theta, then it is possible. Just take sec inverse x or sec inverse theta as your first function and 1 as your second function. But there is a root over theta. You must remove this root over theta, otherwise it will be very problem for you. So let us take root over theta equal to x. Let us take root over theta equal to x. So theta should be equal to x square. Now take the differential. You know the differential means d d theta of theta into d theta. And d d theta of theta is 1. So it will be just d theta. And here x square, that means d dx of x square into dx. So 2x into dx. So here d theta, this d theta can be replaced by 2x dx. 2x dx, and this root over theta is x. So our function is like this now, but you have to change your limits also. So here root over theta equal to x. What are the limits for theta? 2 up to 4. So when theta equal to 2, when theta equal to 2, x will be root over 2. When theta equal to 4, your x will be root over 4, and here the result is 2. So your limit should be root 2 up to 2. Root 2 up to 2. You can take this 2 outside. Now your function is x into sec inverse x dx. X into sec inverse x dx. So you know this sec inverse x cannot be integrated directly. So your sec inverse x should be the first function and this x should be the second function. So put these 2 outside, use a third bracket. So first function into integration of second function. And put the limits for the whole thing. Then whole integration root 2 up to 2 d dx of the first function into integration of the second function. So here integration of x gives you x squared by 2. So x squared by 2 into sec inverse x, and the limits are root 2 up to 2. And here, what is the result of d dx of sec inverse x? We have just seen it. It is 1 by x into root over x squared minus 1. d dx of sec inverse x is 1 by x into root over x squared minus 1. And here, integral of x gives you x squared by 2. So 1 x cancel out, and this half can be taken outside. Half into minus half into this, x by root over x squared minus 1. Now this 2 is multiplied to both the terms, so 2 to cancel out, it will be x squared sec inverse x, and the limit root 2 up to 2, and here these 2 and this half, they cancel out, it will be minus this integration of this. So here it is not possible to evaluate this integral directly. So let us use a substitution here. Suppose x square minus 1 equal to u. So if you take the differential on both sides, it will be 2x dx equal to du. Now, so x dx will be du by 2, half du. And now change the limits. When x equal to root 2, these root 2 and 2 are the limits for x. So when x equal to root 2, it will be 2 minus 1, that means simply 1. And when x equal to 2, it will be 4 minus 1, that means 3. So the limits for u will be 1 up to 3. And here x dx is du by 2, so I have taken this minus half outside. So integral 1 up to 3 du by root 2, because this x square minus 1 is taken as u. So in the next step, you just put down the limits. It will be 2 square. 2 square means 4 for the upper limit, sec inverse 2, minus lower limit. Root 2 whole square means 2, sec inverse root 2. And then perform this integration. 1 by root 2, 1 by root over u means if you take it to the upper side, it will be u to the power minus half. So use the integration formula. It will be u to the power minus half plus 1 divided by minus half plus 1. And here, find the values of the sec inverse 2 and sec inverse root 2. So, if you cannot memorize the result of sec inverse 2, you just write it like this. Suppose that theta equal to sec inverse 2, so sec theta equal to 2. And sec theta equal to 2 means cos theta equal to half. For what value of theta? Cos theta will be half. It is pi by 3, because cos 60 degree is half, and pi by 3 means cos 60 degree. Pi by 3 means 60 degree, and cos 60 degree is half, so theta should be pi by 3. So you see, this angle, this theta means it was the value of sec inverse 2, so sec inverse 2 is simply pi by 3. Similarly, you find sec inverse root 2. So again, suppose that theta equal to sec inverse root 2. So sec theta should be equal to root 2. If sec theta equals to root 2, cos theta will be the inverse of sec, that means 1 by root 2. And 1 by root 2 is the value of cos 45 degree. 45 degree means pi by 4, so theta should be pi by 4. So for the lower limit, cos sec inverse root 2, 2 into sec inverse root 2, so it should be 2 into pi by 4. And here, this minus half remains outside. This is the value of this integral. So this half, in the lower part, you have a half. So when you take it to the upper side, it will be simply 2. So this half into this 2, they cancel out. And your power of u should be plus half, u to the power half, and the limits are 1 to 3. So here 4 pi by 3 minus pi by 2, you do take the LCM. Ultimately, it gives you 5 pi by 6, and here root 3 minus 1. Root 3 minus 1. So this is your result. This is the result for this integration. Okay. How much time is limit? Okay, no time at all. So today also, I cannot give you any math. Do it by yourself. So let us look into this math. integration 1 up to 3 root over x into tan inverse root over x. You know, this tan inverse root over x cannot be integrated. So this tan inverse root x should be taken as your first function. So first function into integration of second function. Put down the limits. Then minus whole integration d dx of the first function into integration of the second function. So integration of this root over x, that means x to the power half. So after integration, it will be, the power will be half plus 1 divided by half plus 1. Half plus 1 means 3 by 2. So x to the power 3 by 2 divided by 3 by 2, that means it will be 2 by 3 x to the power 3 by 2 into tan inverse root x. And here, you know, the d dx of tan inverse x is what? 1 by 1 plus x square. 1 by 1 plus x square. So you just consider this root over x as simple x. So d dx of tan inverse x is 1 by 1 plus x square. And 1 by 1 plus x square means x, because your x is root over x. And then you have to multiply it by d dx of root over x. D dx of root over x, because it was not simply x, it is root over x. And I told you to memorize d dx of root over x is 1 by 2 into root over x. So you put it here, 1 by 2 into root over x, it is coming from this d dx of root over x. And integration of root over x, we have already done it here, it is 2 by 3 x to the power 3 by 2. Okay, now here take this 2 by 3 outside and use the limits. It will be 3 to the power 3 by 2 tan inverse root 3 minus 1 into tan inverse 1. And here these two and these two will be cancelled and 1 over 3 can be taken outside. It will be 1 up to 3. And here it is x to the power 3 by 2 divided by root over x, because ultimately it will come to the denominator. So here 3 to the power 3 by 2 means root over 3 cube. Root over 3 cube means root over 27. Tan inverse root 3 is pi by 3, because tan pi by 3 gives you root 3. Tan 60 degree is root 3 and 60 degree means pi by 3. So tan inverse root 3 is pi by 3. And tan inverse 1, you know, tan 45 degree is 1 and 45 degree means pi by 4. So tan inverse 1 is pi by 4. And here x to the power 3 by 2 divided by x to the power half, that means x to the power 3 by 2 minus half, that means ultimately it gives you simply x. Yes. So 1 over 3 limit 1 to 3 x by 1 plus x. I gave you the technique earlier. In the upper side it is x and in the lower side it is just 1 plus x. So you write the upper part as 1 plus x minus 1 and then separate the two terms into integration. So here it is pi into what? It will be root over 9 into 3 and root over 9 means 3. So 3 into root 3 divided by pi by 3. So 1, 3 cancel out. It will be pi into root 3. And then minus pi by 4, 1 over 3 and separate the terms. The first term will be simply 1. So integral of 1 dx. And the second term will be 1 by 1 plus x. Integral 1 up to 3. So here 2 pi by, okay, this root 3 and this 3, after cancelling there will be root 3 in the denominator. So 2 pi divided by root 3 minus 1, 4 cancel out. So pi divided by 3 into 2, 6. And here minus 1 over 3, integration of dx, so x, and integration of 1 by 1 plus x. It will be simply ln of 1 plus x. You can directly write it, or if it is a problem to you, you just give a substitution for this 1 plus x. Take 1 plus x equal to 2. But without using the substitution, you can directly write down the result. It will be ln of 1 plus x, because if you differentiate this 1 plus x, it gives you just 1. It gives you just 1. That's why you can write down the result directly, ln of 1 plus x, and then put the limits 1 up to 3. So here for the upper limit, it will be 3 minus ln of 1 plus 3 means ln 4. And for the lower limit, it will be minus 1, it will be plus ln of 1 plus 1 means ln 2. So 2 minus, you see, If you take minus sign common, it will be ln of 4 minus ln 2. So ln of 4 divided by 2, that means simply ln 2. So this is the result. Okay,
মিস আমাদেরকে অ্যাটেন্ডেন্সটা নেওয়া হয়েছে
নেওয়া হয়নি. So
এন্ড মিস
let me do it
আমাদের
now. Let me do it now.
আজকে বোধহয় কুইজের সিলেবাসও দেওয়ার কথা
হ্যাঁ. Just a minute, let me submit it at first.
মিস আজওয়াদ মানে ডিসকানেক্ট হয়ে গেছে, তার নেটওয়ার্কে অনেক প্রবলেম হচ্ছে, তো ফলো করতে পারছে না, বললো আমাকে। একটা স্টুডেন্ট বেসিক্যালি তার নেটওয়ার্কে অনেক প্রবলেম, তো সেটার জন্য সে ডিসকানেক্টেড হয়ে গেছে।
ডিসকানেক্টেড হয়ে গেছে। আচ্ছা, এখন ওর জন্য কি করা যাবে?
ম্যানুয়ালি তাকে নেওয়া যায়।
Just a
ও
minute.
কি 10 মিনিট বা 15 মিনিট ছিল